Good morning, students. So in last class we are discussing about theories of complex compounds. In that Werner theory is over. Second one VBT we discussed. So after the failures of VBT, one more theory is came, that is the CFT. So crystal field theory. So now we are going to discuss about crystal field theory. It is simply also called as a CFT. So in this one by one we will discuss first point, complex contains. So complex contains a central metal ion. So central metal ion and ligands. So this is common, but in between them, so that is strong electrostatic attractions. Strong electrostatic attractions. So it is similar to ionic bond present between metal and ligands. So according to VBT, what they told, central metal ligand has coordinate covalent bonds. So that is our VBT. Now this is a CFT explaining is that central metal is there, ligand is there, in between them electrostatic attractions. Electrostatic attractions is nothing but ionic bonds are present in that. That to be unit electrostatic attractions. So unit wise you can plus 1. Suppose plus 1 minus 1. Suppose plus 2 minus 2 means plus 1 plus 1 minus 1 minus 1. Like that unit electrostatic attractions are there. Next, second, d orbital. So d orbital has 5 subshells are there. 5 suborbitals are present. If you see their orientation, so based on the orientation they are classified into 2 types. So in what way? Suppose m value you are seeing means minus 2, minus 1, 0, plus 1, plus 2. Total 5 suborbitals are there here. So central one is a dz square. Next one dxz, dyz. Next one is dx square minus y square. Next dxy. So middle one is z. Next one is related to z and other one. So next last one is without z combination. In this 5 orbitals orientation if you see, then they are observed like you take dx square minus y square. So this is in what way? X axis, y axis upon that orbital is like this. Next dz square. If you see z square, so x axis, y axis, z. So actually x square minus y square and dz square both are present on the axis. These two are present on the axis. So these are called as EG, doubly generated orbitals. So EG orbitals, that means doubly generated orbitals. Next, remaining 3 if you see, so dxy. So between x-axis and y-axis, middle the double dumbbell shape is observed. dyz if you see, so between y and z. Next dxz. between x-axis and z-axis, middle only double shape. So these two are present on the axis, you called as EG orbital or doubly generated. Now these three are observed between the axis. So between the axis, and they called as T2G orbitals. So this is a triply generated. So the d block elements are d block suborbitals are classified into two types. See, what are that? D orbital. So is classified into two types. In what way? EG orbitals, T2G orbitals. So EG are what? Dx square minus y square dz square. Next T2G means dxy, dyz, dxz. These three. So this is the second point. Next important is EG orbitals present on the axis. T2G orbitals are present between the axes. Next, if you see the third, see suppose the d orbital in the ground state. Ground state d orbital. If metal is surrounded, some ligand is coming. Suppose if ligand is coming towards metal means this ground state is excited and occupying degenerated level. Degenerated level. See, this is energy level if you see. Suppose this ligand is coming very close to the metal. So while in what way the ligands are coming, either on the axis they are coming or in between the axis they are coming. Based on that, this is splitted into two types. So suppose these are coming on the axis. Who are present on the axis? EG orbitals. So that's why EG orbitals are feels more repulsions and they are going above. So what are that? Dx square minus y square dz square. This is dxy, dyz, dxz. So this is a degenerated energy level. So these are going down, these are going above from the degenerated level. So when ligand is coming close, the ground state becomes as degenerated. Ground state energy is little bit increases. If it is coming very close, so in what way they are coming on the axis, Eg going above. If the electrons are, that ligands are coming between the axis, then T2G is going above. So that means it is ligands are coming. Ligands are coming on the axis. So who is present on the axis? EG orbitals. They feel more repulsions, energy increases. Suppose if you write T2G is above, EG is down. So when this is happened means if ligands are coming, between the axis, if ligands are coming between the axis, T2G above, EG is below. If ligands are coming on the axis, EG is above, T2G is below. So that point is very, very important. Next, fourth. See, suppose it is perfectly explained about color properties also. So color property means, first of all, before going to discuss about color, what original color is observed. Say, suppose one object is there. one object, we are sending light. We are sending light on the object, then what happens? Something is absorbed. Some amount of light is absorbed, some light is emitted. So this emitted light, if you see with our eye, if we see with our eye, it is looking as a color. So mainly how the color is coming means, upon object some light will fall and something is absorbed, remaining is something is emitted. So if emitted light, if you are falling on our eye, so then you can see the colors. Next, who is responsible for this emitted means, emitted light, that is unpaired single electron. Unpaired single electrons are the responsible for the colors showing. Already in D block elements we studied. So same concept if you see here. So what happens? See, in the presence of ligand, this theory is explaining that the degenerated d orbitals are split into two types. Suppose if electron is here, unpaired single electron is here. So now the light is falling on the compound. So H nu we call as sunlight or light. So if light is absorbed by this unpaired single electron is taking this light and it is excited to occupy high energy. So highest energy it will go. So energy is related to stability in what way? That is inversely proportional. So when light is falling on the compound, the unpaired single electron is absorbing the energy and it is excited to occupy high level. So highest energy means stability is low. So that's why again the electron is coming to down because of stability. So while coming down, whatever the energy is absorbed, that is coming outside as a color, and also you call it as a radiation. So that's why the D block elements are showing colors. In one word only we must tell, means in what way you can tell the who is responsible? Unpaired single electron. So where it is jumping from T to G orbital to EG orbital. This is also D orbital, that is also D orbital. So that's why simply we can tell the reason for color. The reason for color. So what is that? Unpaired single electron transition from D to D orbital. So the electron transition from D orbital to D orbital, either T2G to EG or EG to T2G. So this is one word question you can write. Suppose in theory also they will ask, explain the color property of a complex compounds. Then what you can write? So in ground state metal, when ligand is coming close to the metal, it is excited and occupied degenerated level. When ligand is very close to the metal, then it is split into two, either T2G and EG. That is, when light is falling on the T2G orbital, electron is excited and occupying high energy level. Due to instability of high energy, it will come back to ground state. In the meanwhile, whatever the energy absorbed, that is coming outside as a radiation or color. In your theory, you explain like this. In entrance point of view, they will ask what is the reason for color. So unpaired electron transition from d orbital to d orbital. So that is the fourth point of CFT. Next. So this theory is also explained the order of the strength of the ligands. This theory explains the strength of the ligands. So by using So electrostandard reduction potential, otherwise the values. In what way? That shortcut I will give. So iodine. So electrochemical series. So electrochemical series is given. So these are explained the strength of the ligands. So that is eyebrows. So nucleophore. F minus and OH minus also same. Next, these all are weak field ligands. First line, it is a weak field. These are weak field ligands. Next, strong field ligands. Another line. After that, water. EDTA. Ammonia. Pyridine. VANP. N. Ethylene diamine. Bipyridine. Orthophenol NO2 minus, cyanide minus, carbon monoxide. So these all are strong field ligands. So very weakest means what? Iodino, bromino, chlorino, fluorine. So halogens are weak field ligands. That is next. Who are very strong? Cyanide and very strong field ligands. So these are perfectly, this theory CFT is perfectly explained. Who are the weak field ligand, who are the strong field ligand, who are the moderate. Suppose ammonia and water EDTA you are taken middle of this. So that is through electrochemical series he explained the things. Next, another failure is what? In the presence of strong field ligand, electrons are pairing. In the presence of weak field ligand, electrons are not paired. That is also perfectly explained by the CFT. Next, sixth point. So CFT perfectly explains. So why electrons are paired in strong field ligand and why electrons are not paired in weak field ligands. See, if you see the ground state, so D block orbital ground state, next excited, so that is the degenerated level. Next, you take a strong field ligand, so T2G and EG. It is a degenerated level. See, in the presence of strong field ligand means what? Repulsions are increases. Repulsions are increases means energy increases. So this is happened in the presence of strong field ligand. Suppose you take weak field ligand. So weak field ligand means repulsions are less. Repulsions are less means the T2G and EG energy gap is very small. So this is a ground state. Next, this is a degenerated level. This is also degenerated level. Next, here it is the presence of weak field ligand. See, in the presence of strong field ligand, more repulsion is there. More repulsion is there means large energy gap is observed between EG and T2G. If coming ligand is very weak, so d orbital is also splitted into very small gap. So that is. So now what happens if you are filling the electrons? Suppose first electron first electron is present in 1 only. That is T2G 1, EG 0. Next, in weak field also, first electron you can take 1. Next, second electron you take here. Here also second electron is same. Now, third electron you can write here. Say, after a half filling, next the fourth electron. Suppose you see the fourth electron. Here energy gap is very large. So that's why fourth electron is not going to here. So that's why fourth electron combining with the first only. Now here coming. So fourth electron, here energy gap is small. So fourth electron is going above. Next, fifth electron is not going above. It is combining with this. So now here fifth electron will go above because of gap is small. Now sixth electron is not going above. It is combining with this only. But sixth electron, now it is coming to here. So that means what happens, in the presence of a strong field ligand, electrons are paired. So here, electrons are paired. Here, electrons are not paired. So in valency bond theory, this is the one of the failure. They are told that in strong field ligand, electrons are paired. And in weak field, electrons are not paired. That theory is not explained. Now CFT is perfectly explained that. And one more, in entrance point of view, they will ask why they are pairing. So pairing energy is less. Pairing energy. Electron pairing energy is less compared to splitting energy. This energy you call as splitting energy. So compared to splitting energy, pairing energy is less. So that's why they are paired. But here, pairing energy is very high. Electron pairing energy is very higher than splitting energy. This is a splitting energy. So d orbital splitting energy. So here highest energy is there. So that's why electrons are not pairing. So in one word question means this is your answer. This is entrance, this is a theory. So next, sixth electron is over. Where will go 7? 7 electron is here. So here, seventh electron is combining with the second. Next, eighth electron is here. Now, eighth electron is here. Now, ninth electron is combining with the seventh. Here, ninth electron is combining with the fourth electron. So, 10th electron combining with the 8th electron. Here, the 5th electron combining with the 10th electron. So, the main important, in the presence of strong field ligand, electrons are paired. In the presence of weak field ligand, electrons are not paired. Next, which is a strong field ligand, which is a weak field ligand, also explained our previous electrochemical series. So, that is also over. Next, another important, the seventh point, the stability of complexes. So, stability of complex compounds is explained by using CFSE values. So, they are explaining about CFSE, crystal field stabilizing energy. So, crystal field crystal field stabilizing energy. Based on this, they are going to explain. So, in what way it is splitted? So, splitted you are taken one unit. So, it is suppose octahedral, delta 0. So, one unit you can feel means, so these are moving down. So, these are moving down means how much? Here 6 electrons, here 4 electrons. How to balance this one? this is multiplied with 4 delta 0. So from the degenerated level it is decreases, they are taken as minus 4. Next, here to here. So here 4 electrons are there. How to balance this one means here 6 electrons. So you can take as plus 0.6 delta 0. So EG orbitals, so they are moving from the degenerated level to top side. So indicates the plus. So now CFSE values, how they are taking means number of electrons in T2G into minus 0.4 delta 0 plus number of electrons in EG orbitals into plus 0.6 delta 0. So based on this formula, they are explaining about the stability of the complexes. So these are the main important points about CFT.